Welcome everyone. In this video I will talk about monolithic versus microservice architecture. I'm pretty sure that most of you have heard about those terms, but if you're curious to know what they really mean and what are some pros and cons of using each one of those, then let's get started. Before we go into details and discuss both of these, firstly, let me say that both these monolith and microservices are software architectural styles. These are the way we design our software. And usage depends on the business use case. I have heard many people say that, monolith is bad, it's outdated, etc. But the thing is that monolith also has its own place, as well as microservices, right? So monolith does not automatically means that it's bad. It really depends on the use case. Sometimes monolith makes sense, sometimes microservices make sense. So decide the usage based on your own particular case. Let's imagine we have a very simple booking application, and we will demonstrate the concepts on this app later. So this booking application has four features or functionalities. First one is obviously booking. Let's assume we're booking some rooms. The next one is users or user registration and related things. Payments, so when someone books a room, he needs to make a payment. And reporting. Let's say at the end of the week, we need to generate reports for how many books were booked, how much money they paid, etc. So very simple booking app. What would be a monolithic approach to booking app? Now, in case of monolith, we typically have this huge app, which is represented as a circle in this case, which contains all of our functionalities, right? Functionalities cannot be split. They are part of the same application. And we typically have the same code base for all these four functionalities, so they live in the same project, which in result will give us the same artifact, right? And if you don't know artifact is basically a file that you deploy to the server. For example, in case of Java, that might be a jar file, war file, ER file, right? That you take to the server and deploy. By the way, these concepts are not specific to any particular language or technology. These are generic concepts, generic. So in monolith, I'm sure that you have had some experience with. We have one application. We have all these functionalities together. We have same artifact, and which will result in the same process. So at the end of the day, we will have the same operating system process that contains all these four functionalities, right? And people have been using this for decades, right? And it should have some benefits, because otherwise why people used to use it for decades. And first thing is easy deployment and easy to start developing, right? You just put everything in one place, you create an artifact, and you deploy that one file to the server. It's super easy to deploy, right? And super easy to start developing your application. You're just putting everything in one project. Also, one of the benefits, and this is a very good benefit, is that communication between our functionalities or components is easy, fast, and reliable. Now, we communicate between our functionalities and components via method calls. Since they are part of the same process, same code, they can call each other with methods, right? For example, if you have more distributed service, you need to make network calls, right? In microservices, people typically make network calls. So network is not reliable, it's not fast. Sometimes it's not easy to implement API calls. In this case, we have method calls, which is easy, fast, and reliable. Now, this typically we have one master database, right, in monolith. Now, you might have some replicas, but we have one main database. Assuming we are not using database sharding or partitioning, as some people call it, Most monolithic applications don't use it. Assume we don't use it, right? This is beyond the scope of this video, but typical situation, we have one main database. Since we have one database, master database, it's easy to write queries, right? For example, join queries, select queries. We just need to select things from one database, not multiple databases. And it's faster since those queries run in the same database. It's fast. And we also don't have a consistency issue, data consistency issue, because we have one main database, one master database, one single truth source of truth, right? If we had, let's say, few master databases, right, where we write our data, then we might have some data consistency issues. We might have some stale data in one of our databases. Now, in this case, that's not a problem. And lastly, I put it's easier to test and debug. Now that's a little bit debatable, but what I mean is that since monolithic apps are not that much distributed, in this case, it's when something goes wrong, you know exactly where to look the problem. You know that the problem is in this app. You know which code to check, right? In more distributed systems like microservices, when something goes wrong, you need to identify which service or which component's fault is it, right? So in monolithic approach, since we have everything together, we know exactly which project, which app to check. So in this sense, it's easier sometimes to test and debug. But obviously, it has some drawbacks or cons. First thing is hard to scale, right? And in this case, we don't mean vertical scaling. Vertical scaling has its limitations, right? If you just have one instance, you also have a single point of failure, right? And also in case of vertical scaling, the hardware has its limitations, so you cannot scale infinitely vertically, right? So when we say scaling, we mean horizontal scaling in this case. So let's say we have multiple instances of our application, instance 1 and instance 2. Now, what's the problem here? The problem is that since each functionality, and let me underline here, these functionalities, right, are part of the same process, they cannot be splitted. So they depend on each other, they affect each other. So I cannot scale a separate component independently, right? Let's assume we have a lot of users registering because we have a very cool app, right? So the load to users functionality is huge. What do we need here? We need to scale the user's functionality, right? And the thing is that I have to start another instance, but I cannot just scale users functionality. I have to scale this whole instance, whole app. Why? Because functionalities cannot be separated. I cannot just take the users and scale it, users functionality and scale it. That's not possible because this is one process, right? One project, one artifact. So I need to start another instance which also contains this functionality. So I cannot scale components separately. And this obviously means that I'm scaling other components for no good reason. So I'm not using resources very well, right? This is first reason. The second reason, which is connected to first one, is that let's assume our booking functionality needs RAM, a lot of memory. Our users component needs a lot of CPU power, right? Maybe it's CPU intensive, right? Maybe payments needs a very good network connection. It does a lot of IO calls, right? Now, since they are part of the same process, I need to have a server which has all these good qualities, right? But if I could split them in different services, in different components, in different processes, right? I could find a server which has a good RAM and start booking service there. I could find a service that has a good CPU and find and start user service there. I can find a service that has I can find server that has good CPU network connection and I can start payment service there. So I can allocate the resources based on the need of different services. Here I need to allocate the services, allocate the resources to the whole thing, right? So I don't have that much flexibility. And one more thing is that as you see, we have a database here, right? So even though we have multiple instances, they will be still using the same database, right? Databases don't scale that well. You might have a read replicas, but you will have typically will have one master database. So you still might have bottleneck in a database since we have one master. That's another thing why it's hard to scale. One more thing is that imagine the situation when we need to update something in the booking service. Just one line. What I need to do is to update or redeploy all instances, right? Why? Because other things are part of the same process, same artifact, same code base, right? So when I need to update one thing in one functionality, I have to redeploy all my instances, which is, I mean, if in this case we have two instances, but let's say we have dozens of instances. So do you want to redeploy and update the all instances because you changed one line in one functionality? Probably not. So for these reasons, it's a little kind of hard to scale horizontally. And let me remove these lines. Next one is it's less resilient, right? Resilience means if something goes wrong, right? What happens? Do we have some partial failures or does our system crash entirely? So in this case, if something goes to, let's say, booking functionality, let's say we are out of memory, it will bring down the whole process, meaning that it will affect other functionalities, right? So in this case, it's less resilient. We might have full failures instead of partial failures. Hard to maintain. Now that's a little bit debatable and it depends how you write the code, but typically when the code base grows a lot, you have a lot of functionalities. Things typically get quite tightly coupled. And when you update one thing, you need to take care of other things, and it's just hard to understand what's going on. So it's hard. It becomes hard to update, hard to refactor, hard to maintain, especially when the code base grows. And this brings another point that it's hard to take ownership. It's hard to bring new developers to the project because you have one huge thing where everything is tightly connected if you don't write it in a good way, right? And then lastly, all functionalities is bound to the same technologies. What do I mean by this? For example, booking. I cannot write booking functionality, let's say in Java, users in Python, payments in C#, and reporting in PHP. Why? Because these four functionalities are part of the same application, same code, same process. So I'm bound to use the same technologies, same programming languages to all these functionalities, right? In microservice world, you could have different programming languages or technologies for different services. And sometimes it's very, very good. So these were the drawbacks or cons of using a monolithic approach. And by the way, guys, I want to say that currently we have 72 subscribers, so we are 28 subscribers away from 100 subscriber mark. So if you learned something, if you find the content valuable, please consider to subscribe. It really helps the channel grow. It really helps me out. And by the way, if you have some questions so far, if something is not that much clear, write down in the comment section and I will try to answer all of your questions. So far we discussed a monolithic approach where we have one big app and we put all of our functionalities inside that big app. And in the end, we have one process, operating system process, which contains all of our functionalities. Now, in microservice world, we typically split that functionalities, that responsibilities or our business domains into different services. Okay, those are independent from each other. So each service has one responsibility, one idea right? And each service also has its own data store. So, for example, Booking has its own database, Users has its own database. So all our services have their own separate data store. There are many ways people define microservices, but typically what most people mean when they say microservice, they mean that we have a collection of independent services, typically small services that work together, right? And remember that in Monolith, we had one code base, one artifact, one process. In this case, we have different code bases, right? These are different projects, different small apps or different services, which result in different artifacts, right? In this case, we would have 4 artifacts, which would result in different processes, 4 processes, which will typically be run in different servers, right? So bottom line is that we split our huge app into multiple components which are independent from each other, autonomous from each other, and each has one goal, one responsibility, and each also has its own separate data store. Now, why this is a good approach, or why do we have some benefits? Let's discuss the benefits. It's easier to scale. In Monolith, we had the problem of scaling, right? Why? Because we couldn't separate our components. They were part of the same thing, same entity. Now, in this case, since we separate our components into different services, different artifacts, different processes, right? I can scale each one of those independently, right? For example, if I have a huge load on Booking, I can start multiple instances of Booking service, and I do not affect other services, right? Those services are not affected. In Monolith, I could not do that. I only could scale things together, right? Which is not good resource-wise. So in this case, I can just scale one service or one component based on its needs, right? In Monolith, when our services have different resource needs, I need to find or have a server that has all these good qualities, right? Booking, as you remember, Booking needed a lot of RAM, a lot of memory. Users, a lot of CPU. So in this case, I can find the server that has a very good RAM, but maybe not good CPU. And in this case, it works because this service is separate. It's a separate process. It's a separate application, right? Separate service. So I could do that. I could find a server which has good RAM and start Booking there. I could find a server which has a good CPU and I can start my users there, user service. I can find a server that has a very good network connection and maybe not good RAM or CPU, and I can start payments there. So I have far more flexibility, right? I can scale them very easily. And again, I will repeat that in scaling, we mean horizontal scaling. So scaling is easier. We also have easy deployment or update within the scope of a single service. Now, if you recall, in Monolith, if we needed to change even a single line in Booking, for example, or any other service, we needed to redeploy our instances, right? Because they were part of the same process and we could not separate them. In this case, since they are separated, if I need to update in one line in Booking, I only update in this service and redeploy this service. So those services, users, reportings, payments, they are not affected. They don't care, right? So it's easy to update one service and deploy it. More resilient partial failures, right? Let's say Booking goes down for some reason. It consumes too much memory. We have out of memory problem. It goes down. Well, my user service might still be up and that user functionality might still be available. So I have partial failures. I can minimize failures. In case of Monolith, if one thing crashes, it will cause the whole thing to crash, right? Technological variety. As you remember, in Monolith, we were sort of bound to same technologies for all functionalities. In this case, I can write my booking service in Python. I can write my user service in Java. I can write my payments in C#, reportings in PHP. So I can use completely completely different set of technologies per service, which is sometimes very, very helpful. And since each service is pretty small because it does one thing, or let me rephrase that, it has one responsibility, one idea, right? Uh, it's very easy to bring new developers in because typically those services are pretty small, right? And it's very easy to understand them. So it's very easy to take ownership of these services. Now, obviously, when you have benefits, sometimes you have drawbacks or cons or concerns. So what are some of the cons? We have more advanced, complex platform, right? When it comes to deployment, monitoring, security, and testing. Deployment. Now, I said that in the last slide, I said that in the scope of a single service, it's easy to make change and deploy. But overall complexity of our system is bigger, right? I need to have different, for example, CI/CD pipelines for each service, right? Bookings will have each own CI/CD pipeline, users its own CI/CD pipeline. I need to have different servers that communicate with each other, right? So it's more complex overall deployment. Monitoring is also complex. In case of Monolith, we just monitored one app because all functionalities were part of the same process, right? We monitor one process. In this case, I need to monitor four services or four processes. And imagine if we had thousands of services, and Netflix has more than 1,000 services. So they need to monitor all those services. Security. In Monolith, we can reuse the security between functionalities, right? We can implement the security in one place and all our functionalities will use them. Now, in this case, what do we do? Do we implement security per service? Or maybe we have a centralized way that we implement security in a central place and each service will use. So that's the question. And testing. So when something goes wrong, for example, booking service will use payment service, right? So in this case, when something goes wrong, right, what do we do? Where do we check? Do we check in booking, in payments? So where is the problem? Sometimes it's hard to understand when we have more distributed system, and microservices are more distributed system than Monolith. So overall complexity is greater. We need more complex platform, more tools or more complex tools, but we have tools for that. Second one is data consistency. Since we have different databases here, master databases here for each service, right? Sometimes it can happen that we might face with data consistency issue, right? We might have some data in a booking and some old data in booking and some new data in payments, which are related to each other. So what do we do in this case? Data is not consistent. So that's a problem, typically. And I also wrote query complexity here because let's say look at reporting service, right? It needs to gather data from all these services to report, right? In this case, in case of Monolith, the data was in the same database. So reporting service will just go to one database and get it. Now it needs to reach to different services. It cannot go directly, by the way. So each service database is not accessible from other services. This reporting should go to user service, ask some data, go to booking, ask some data, go to payments, ask some data. So queries become more complex. We need to have a different views of queries. It becomes more complex. And communication between services is harder. Now, services typically communicate through API calls via network. So network is not reliable sometimes. It's not fast sometimes. So let's say what happens when booking calls payments and that call fails. What do? Do we retry again? Do we wait? Right? It's complex. In case of Monolith, we just had method calls, which is extremely easy, extremely reliable, and very easy to implement, right? So these are some drawbacks or cons of using microservice approach. Now, this very, very important question, which one to use, right? as I said in the first slide, there is no silver bullet. There is many people say that Monolith is bad, it's outdated, but that's not the case. Monolith has its own place, right? Microservices has its own place. So when you need to decide which one to use, what I want you to do is that just write down for each architectural style on the left-hand side, what is the benefit in your particular use case, right? And what is the cost in your particular use case? And compare them. If the benefit of using, let's say, microservices or monolith is greater than the cost, right? In that case, I guess it makes sense to use that particular architectural style. So write down the benefits and costs. So do cost benefit analysis, and if benefit is greater than the cost, it probably makes sense to use it. This was all for now. I hope that you learned something today. If you still have got some questions, if maybe something's not clear, write down below in the comment section and I will try to answer all of your questions.